Good evening, students. I hope you're all doing fine. Welcome to a new lecture. So, let's start with today's topic. As you know, last time I had said or we had completed with indefinite integration. So, today we are going to start with definite integration. I hope my voice is clear. If not, you can say, but I hope it is clear, right? Chalo. So, when we think of definite integration, let me tell you what we are going to do today. Today, we are going to do these three things, which is the fundamental theorem of definite integration. Second are the properties, which is the base of definite integration. And third is PY. Now, as you all know, that in indefinite integration, there are many functions whose integration is not possible. But in the case of definite integration, we can integrate those types of functions by using properties. Got it? So basically, if you have an idea, definite integration helps us to give area under the curve. Now, let's see what is definite integration, the basic introduction. So, first is fundamental theorem, which means that if integration of f of x dx is g of x plus c, then if I say what is integration a to b f of x dx, so it will be g of b minus g of a. As you can see, in case of definite integration, there is no c, means no constant of integration because it gets cancelled here. Got it? So that means this we all know that what we do in definite integration, we integrate the function and we do upper limit minus lower limit. Got it? A is called the lower limit and B is called the upper limit. Now, here I will focus on the questions based on properties. Correct? Like we will not solve the question indefinitely and then we'll do upper limit minus lower limit. Got it? We'll use properties to solve the questions because we have done many questions in indefinite integration. So let's first just check the basic on how to use the upper limit and lower limit. Very simple question. So this I can write it as x square ka integration x cube upon 3 minus x ka integration x square upon 2. What are the limits? It is from 2 to 5. So if I put upper limit, I'll get 5 cube upon 3 minus 5 square upon 2. This is upper limit minus lower limit is 2 cube upon 3 minus 2 square upon 2. Right? So what I'll get? I'll get 125 by 3 minus 25 by 2 minus 8 by 3 minus 4 by 2. Now this term and this term, these both terms, we do not have to take LCM. So if I do 125 minus 8, what is 125 minus 8? I guess 118 or 117 upon 3, right? Minus 25 minus 4. So it will be minus 29 by 2. So if we can calculate this, it is very simple. We will get an answer. Got it? So this is the way of calculating definite integration, just upper limit minus lower limit. I just wanted to give you this example for like revision types, basic questions. So now let's move on to the main part of definite integration. Achha, you calculated plus 4 by 2. This is a divisible, na? 3, 3s are 9, 3 9s are 27. So 78 minus 29 by 2. Okay, Achha, I made a mistake here, right? Here, The sign I made, na? Here it should be plus. Got it, got it. Thank you, thank you. So it will be minus 21 by 2. Yeah, right. Thank you. No problem. Chalo. So let's move on to the properties. Here, the first property is very simple, as you all know. It is if the upper limit and lower limit are same, then the integration value is 0. Second property is the change of upper limit, lower limit. If I change the upper limit and lower limit, then there is an inclusion of negative sign. What is the third one? Third one is the change of variable. I can anytime change the variable from x to t or x to w or any variable. The fourth one, let me tell you, first, second, third properties are like no use. Basically, we'll never or sometimes use basic properties. Fourth property say we'll get some important properties. Fourth property is mainly used for non-uniformly defined functions. Non-uniformly defined functions means example mod x or step of x and so on. This means this property says that if my integrand is from a to b, then I can split it at c. So I can write a to c plus c to b. I can write it a to c plus c to b. I hope it is clear. So this splitting at c is done where the function is non-uniformly defined, or in simple language where the function is discontinuous. Got it? We'll see such examples. Next, let's see the examples of this. Suppose this is the question. So as we all know, modulus function is a non-uniformly defined function. Or suppose we have to break it somewhere. So here it is -1 to 1 mod of 5x minus 3. Now can you tell me where do we break the function? We break the function where 5x minus 3 equals to 0. That means x is equals to 3 upon 5. After this, we make a number line. This is 3 upon 5. If my value of x is greater than 3 by 5, then mod value is positive. And if less than 3 by 5, then mod value is negative. So that means I need to split the integrand at 3 by 5. I hope you are getting it. If I do the theoretical way, that means mod of, I can show you both ways. This is the theoretical way, this is the normal apna, short form, or the way we use in MCQs. So mod of 5x minus 3 is equals to 5x minus 3 when x is greater than 3 by 5, and is equals to minus of 5x minus 3 when x is less than 3 by 5. So any definition you can use. That means integration or split the limits at 3 by 5. So I'll split -1 to 3 by 5 plus 3 by 5 to 1 by using property number 4. Now here -1 to 3 by 5 means, this is the definition, means I will get 3 minus 5x. And here 3 by 5 to 1 means I'll get 5x minus 3. The integration is very simple. What we'll do here? Integration of 3 is 3x minus 5x square by 2. What are the limits? It's from -1 to 3 by 5 plus. Similarly here, 5x square by 2 minus 3x. What are the limits? From 3 by 5 to 1. You can calculate these by calculating upper limit minus lower limit. I am not calculating it here because I hope you know how to calculate upper limit minus lower limit. As usual, I am weak in calculations. You pointed out my mistake here, so it's fine. Calculation part, I give it to you. I hope you can calculate it. Got it? Here we are just for how to approach a question. Now, we saw mod function. Let's look at step function. So next is integration 0 to 3 x into step of x dx. The step of x is or greatest integer function, right? So here the limits are from 0 to 3. That means x is from 0 to 3. So step of x is a non-uniformly defined function. So what is the value of step of x? It is 0 when x is between 0 to 1. It is 1 when x is between 1 to 2. It is 2 when x is between 2 to 3. So that means where do I need to split the limits? I need to split the limits at 1 and 2. I need to split the limits at 1 and 2. That means I can write it as 0 to 1, 1 to 2, and 2 to 3. Right? Now x will remain as it is everywhere. This I am splitting by property number 4. Step of x. If it is between 0 to 1, step of x is 0 plus. If it is between 1 to 2, step of x is 1 plus. If it is between 2 to 3, step of x is 2. So here this will get cancelled. That is, this will be 0. So what I'll get is 0 plus x ka integration x square by 2 from 1 to 2 plus 2x square by 2 from 2 to 3. Here 2 will get cancelled. So again, I'll do this calculation. This looks easy, right? So I'll get 2 square by 2 minus 1 by 2 plus 3 square minus 2 square. So this is 2 minus 1 by 2 plus 9 minus 4 is 5. So 5 plus 2, 7 minus 1 by 2, it is 13 by 2. I hope it is correct. So my final answer is 13 by 2. So these are the basic questions to use the property number 4, which is splitting of limits. Whenever we have non-uniformly defined function, mod x, step of x, etc., that means we have to use the property number 4 to split the integration. Now, let's look at more interesting properties, which is 5 and 6. Basically, 5 and 6, the properties you may know, it is known as the king of all properties, or we tell it the king property. If you know, I read it in a book. I also didn't knew when I was studying, but after some time I read it somewhere in a book where these properties are basically known as king properties. What does this say? Like, this says that if my integration I is from a to b f of x dx, then I can replace x, or let me tell you, I can replace the variable by upper limit plus lower limit minus variable. I can replace the variable by upper limit plus lower limit minus variable. That means I can replace here x by a plus b minus x. After replacing this, my I will remain same. It will remain same. It will not change. But my integrand will now become f of a plus b minus x dx. This becomes my integrand. So the second property, this 6, is just a special case where here we have 0 and here we have a. It's just a special case. Here it is general case, which is a and b. Same thing we can use. Now, how to use this property? So basically, many a times, what we do is we mark this as 1 After using property, we mark this as 2. And most of the times, do you remember? We add. That is, we do 1 plus 2. So we get 2i equals to something. Most of the time. I'm not saying every time we will add. This is most of the times. We will add 1 and 2, and most of the time my question will get simpler or my question will get solvable. Got it? Now let's see what we can do. We like the given question as mark it as 1. We'll apply king and the applied king will mark it as 2. And most of the times we'll add, like we'll do 1 plus 2. Got it? I hope it is clear. Let's look at some questions. This one. It is a very good question. So, before proceeding or before applying king, I would say ki convert tan into sine and cos. Then you will be able to see easily. So, if I convert tan into sine and cos, tan x can be written as cube root of sine x upon cos x. Correct? If I take LCM, I will get integration 0 to pi by 2. LCM लूंगा तो ये ऊपर आ जाएगा. That is cube root of cos x upon cube root of cos x plus cube root of sin x. Correct? Now, we will mark it as 1. What we'll do? We'll apply king. What king says? That I can replace the variable with sum of upper limit plus lower limit minus variable. That is, here I can replace x with pi by 2 minus x. And the value of I will remain unchanged. So I'll get integration 0 to pi by 2. Now, if I replace x with pi by 2 minus x, I will get cos 90 minus theta or cos pi by 2 minus x. If you know allied angle, what is cos pi by 2 minus x? It is sin x. So cos pi by 2 minus x, in numerator, I'll get sin x. Similarly, in denominator, also here I'll get sin x plus here sin x. Sine of pi by 2 minus x, which is cos x. This is equation number 2. Now, what is the third step that we do? We add 1 and 2. So, on left hand side, I'll get 2i. And if you can see, the limits are same from 0 to pi by 2. Means I can take the integration common. What I'll be left with is, here I'll be left with cube root of cos upon cube root of cos plus cube root of sine plus cube root of sine upon cube root of sine plus cube root of cos. There is no need to take LCM. Why? Because the denominator is same. So what I'll get is, I'll get the same thing. That is cube root of cos plus cube root of sine upon cube root of cos plus cube root of sine. That means this will get cancelled and I'll be left with integration 0 to pi by 2 1 dx. Now don't forget, this is a value of 2i. Many a times I personally make this mistake. That is, in the final answer, I select the answer of 2i, not I. So many a times I've lost my marks in tests like this. So I hope you don't do the mistake. What is the integration of 1? It is x from 0 to pi by 2. That is, my answer will be pi by 2. No, my answer will be pi by 4. This is what I was talking about. Many a times you must have also made the same mistake. That is, you in the options, you must have marked pi by 2. But it is a value of 2i. We wanted I. So my correct answer should be pi by 4. I hope it is clear. It is a good question or very simple question, I would like to say, for using the king property. Got it? Again, what is the steps? One property, two add, and we'll get our answer. Most of the times we'll add, but not every time. Till here, if it is clear, you can give me a thumbs up, or you can like say yes, no, anything. Till here, any doubts you have? Okay, okay, very good. Chalo, super. Let's move on to the next question. Here, what we have here? Here we have integration 3 to 8, 11 minus x the whole square upon x square plus 11 minus x the whole square. So what we'll do, we'll mark it as I and equation number 1. Now we are going to use king. What does king say? King says that I can replace the variable with upper limit plus lower limit minus variable. That means I can replace x with 11 minus x. So my I will remain same. I get integration 3 to 8. X ko I'll replace with 11 minus x in the integrand upon 11 minus x the whole square plus 11 minus x the whole square dx. Now, as you can see here, 11 will get cancelled and I'll be left with integration 3 to 8 x square upon 11 minus x square plus x square dx. What I'll mark it as? Add 1 plus 2. If I add 1 plus 2, on left hand side I'll get 2i, integration 3 to 8. On the right hand side, if you can see, the denominators are same. That means I can directly take LCM and numerators mein I'll get 11 minus x square plus x square dx. And you can see same, it will get cancelled. So I'll get integration 3 to 8, 1 dx. That means x from 3 to 8. That means 5. But this is the value of 2i. That means what is the value of I? It is 5 upon 2. Clear? These are basic questions. Many times we'll use like this. Now let me tell you, when we do some previous year questions, which is basically today, I have previous year questions from the JEE Main 2020 and 2021. I have collected the definite integration questions, good questions from all the shifts, and I have presented here. When we'll do these questions, I want you to remember that the questions we are doing now, like this one and this one, these will be a part of those questions. I hope you are getting it. These questions will be a part of those questions. So if we are familiar with these questions, those questions will be very smooth. Got it? So let's move on to the next one. Here, integration 0 to pi x into sine square x dx. Now, let us think about this for a while. Suppose if I did not have x square, if I did not have x, then the integration of sine square x is very simple. I can do it very easily. But here, due to this x, we cannot do the integration indefinitely. Correct? You must think we can use integration by parts. Yes, but it will be very lengthy. So, these types of questions are very, very common. Here, I like to say, or I like to tell these types of questions as the problem of x. The problem of x. Why the problem of x? Because if this x was not there, integration of sine square x would be very simple. Therefore, these questions are called the problem of x, or I would like to call it as problem of x. Now, such questions can be easily solved by using king. If I use king and then add, my x will get gayab. We'll see sometime. So if I use king here, that means I'll replace x by pi minus x. So I will remain I'll get integration 0 to pi minus x into sine square x dx. Sorry, sine square pi minus x dx. Correct? What is sine pi minus x? It is pi minus x. Sine pi minus x is sine x. Allied angles. So I'll get integration 0 to pi minus x into sine square x dx. This is equation number 2. What we do now? We add 1 plus 2. So I'll get 2i is equals to integration 0 to pi. As you can see, in both 1 and 2, sine square x is common. So if I take sine square x common, what I'll get inside? I'll get x plus pi minus x. So as you can see, the x gets cancelled. This is what I was talking about. The problem of x can be easily solved by using king and add. After doing king and add, the x will get cancelled. So if you can see, I'll get 2i is equals to, I can remove pi outside, integration 0 to pi sine square x dx. Now the integration of sine square x is very simple. What we can write sine square x as, I can write the sine square x as 1 minus cos 2x upon 2. And I can remove 2, so I'll get pi by 2, integration 0 to pi, 1 minus cos 2x dx. Both of the functions are integrable, that is pi by 2. What is the integration of 1? It is x cos 2x ka sine 2x upon 2 from 0 to pi. So I hope you'll calculate now. I don't need to calculate upper limit minus lower limit. So I'm not calculating. I just need to know that after studying queen, the next property is queen. King ke baad queen. We will not do these questions. Like we will not have to integrate indefinitely after studying queen. After studying queen, in this step, we'll apply queen. We'll see the questions. That means by using king and queen, we'll get the answer without ever integrating the function. Right? This year, we integrated the function. Right? So after using queen, we should not, or we will not ever use integration. Got it? I hope it is clear. It will be more clear when we study the next property. Got it? So that's why I'm not interested here in calculating these values, because I know that we can use queen here and we'll get directly in 2 steps our answer. So let's move on to the next property, which is the queen. Now, queen basically helps us to half the limit. Like here, as you can see, the limit is 2a. After using the property, it becomes a. That means the limit gets half. So basically, this property is known as queen. How to use this, right? This is a property, but let me show you how to use it. I can write it as integration 0 to a. I can take common and write f of x plus f of 2a minus x dx. Now, this will be equal to 2 times integration 0 to a f of x dx if f of 2a minus x is equals to f of x. As you can see, if these both become same, then this will be f of x plus f of x, which is 2 times f of x. Got it? And this will be equal to 0 if f of 2a minus x is equals to minus f of x. I hope it is clear. This will become 0 if f of 2a minus x is equals to minus f of x. As you can see, if this becomes minus f of x, these both will get cancelled. Correct? So this is the way we use the property. That is, what we'll do is, we'll first check these conditions. We'll first check these conditions. And if any of these conditions is applicable, that means we can use queen. Again, let me tell you, the lower limit should always be 0, right? The lower limit should always be 0. Then we'll check these two conditions. If any of the conditions satisfies, then we can use queen. So now the order or the order of application of properties. That is, first we'll check if queen is applicable, and second then we'll check if king is applicable. So first priority हमेशा किसको दी जाएगी? क्वीन को. लेडीज फर्स्ट. Priority of property is always given to queen, and then we'll use king, right? So let's look at the question. Okay, let's look at first another property. This is the last or second last property I would like to say. This is the similar property to queen. As you can see, this property is similar to queen, but here the limits are minus a to a. These are the very unique limits. Minus a to a. These are unique limits. In any question, we can easily see minus a to a limits. So if my limits are from minus a to a, I should think of this property. That is even odd property. This says that if f of x is an even function, I hope you know the definition of even function. Even function means f of minus x will be equal to f of x. And if it is an even function, I can write this integral as 2 times integration 0 to a. Now, you can see it is similar to queen, right? But not exactly as queen, because queen may lower limit we have 0. So don't get confused here, please. And if f of x is an odd function, what is the meaning of odd function? That f of minus x will be equal to minus f of x. I hope it is clear. So then my integral will be 0. So here we only need to check two things. Again, similar to queen. I can check this condition, even function condition, or I can check the odd function condition. If any of these conditions are satisfied, then I can use this property. Got it? So both this property I have done simultaneously because both looks similar. But don't get confused. Let's look at the questions. This one. Here you can clearly see it is from minus pi to pi. That means I can use the even odd property. So this is my f of x. It is a very good question, actually. So if I check f of minus x, that means this will be minus x into 1 plus sine of minus x upon 1 plus cos square minus x. So I'll get minus x. What is sine of minus x? It is minus sine x upon here I'll get cos square x. So which is not equal to minus f of x or f of x, as you can clearly see. That means the given function is Nino. What is Nino? Neither even nor odd. Nino. Neither even nor odd. I mean the function is neither even nor odd. Now, but if you can see, I cannot integrate this function indefinitely. Or can I? If I can, then it will be very lengthy and I do not wish to integrate it like that. So what we can do here? Any suggestions? If you have seen these types of questions further, you can type it in the chat box or you can unmute yourself and tell. I want to know your views on this. Any suggestions or should I tell you? I'll give you 30 seconds. Please think. What can we do here? It is very tricky, but I hope you can catch it. I'll have some water. 2 minutes. 2 minutes and 20 seconds. Till then you think what we can do. Chalo, no ideas? Nothing? So let me tell you, in such cases, these cases will arrive many times. Many times. Like mostly such cases we will see in case of the odd and even function. We will split the numerator. See, I can write the integration as, I'll open the bracket here. The numerator, I'll open the bracket. So I'll get x plus x sine x. And after that, I'll split the numerator. So I'll get x upon 1 plus cos square x plus x sine x upon 1 plus cos square x dx. Now look or check very carefully. This function is odd. Please check. This function is odd. And this function is even. We will do such splitting many times. Like in many questions, we will do this. So please understand here. I am giving you some time to think about that this function is odd and this function is even. Please take your time. So please remember, if a function is Nino, neither even nor odd, so one time we can try checking by splitting the numerator. I'm not saying this will work every time, but at least we can check it. So if this function is odd, the value of the integration will be 0. And if this function is even, what was the property for even function? It will be 2 times 0 to a. That means here I can write it as 0 plus 2 times integration 0 to pi x sine x upon 1 plus cos square x dx. Now, the main thing here, how to integrate this? Do you remember the problem of x? If this x was not there, then the remaining function could be integrated very simply. Very, very simple. You can check. But here it is, I cannot integrate it because of x. So this is the type of the problem of x. In problem of x, we can get rid of x by using king. So here I'll use king. King says that I can replace x with pi minus x. Let this be I. That means I will be equal to 2 integration 0 to pi minus x. What is sine pi minus x? It is sine x upon 1 plus. What is cos pi minus x? It is minus cos x. But since we have square, cos square, the minus will be gone. This is equation 1. This is equation 2. What we do after using king? We use 1 plus 2. And I'll get 2I is equals to 2 times integration 0 to pi. I can cancel out these two. What I'll get is, can you add these two? If I try to add these both, you can see x minus x will get cancelled. I am deliberately skipping the steps because you need to think all these things in your mind. Not every step you have to write, because then your speed gets slow. And if your speed gets slow, you might not be able to complete your JEE paper on time. That's why I'm deliberately not writing everything. I am saying so you can think orally in your mind. Get it? So if I add this, as you can see, x will get cancelled. I'll be left with pi sine x upon 1 plus cos square x dx. That means I will be equal to, I can remove pi outside, integration 0 to pi sine x dx upon 1 plus cos square x. Now this is, we can easily integrate this by using indefinite integration. What we can do here, we'll put cos x equal to t. So sin x dx will be equals to minus dt. That means I'll get, limit will also change. I'll get cos 0 is 1, cos pi is minus 1, right? Yeah. So I'll get minus dt upon tan inverse of t. Right now, and you can do upper limit minus lower limit. That means minus pi tan inverse of t from 1 to minus 1. You can do upper limit minus lower limit. I am not interested in the calculations. Got it? I hope it is clear. It was a very good question. First, we used the even odd property by separating, and then we used king to get rid of x. So these are questions which have came in previous year papers. So that's why we are discussing. Let's look at next one. This is also a very good question. So I'll give you 20 seconds to think. So 30 seconds, Dia. Can someone write in a chat box or someone tell me how to proceed or what I can do in the first step for this question? Anything that comes to your mind, we are open to discussion. No need to like say कि हाँ wrong हो गया तो क्या and all. Just like be logical and you can say what we can do here. Come on, guys. Something कुछ तो क्लिक हुआ होगा. Anyone? No idea? Come on. There are 20 students here. 20 में से एक को भी नहीं है. कुछ तो like you have studied integration, indefinite and all. You can say how we can proceed the question. No one? If you'll do like this, then how will I survive? I'll get bored very easily if you'll not discuss with me, if you'll not interact with me. बोर होके मर जाएगा मैं. Come on, no idea. Acha, you understood all the questions and all the concepts before this question? You can at least say yes or no. So I'll get an hint. Before these questions, all the properties, king, queen, all the questions we did you understood all that? Yes. Okay, superb. Very good. One of them gives me thumbs up. What are others doing? Yes, yes. Okay, cool, cool. Very good. Chalo. So no idea about this, right? So this is a very typical sum because I'll tell you, this is standard substitution, right? Now you might get a hint. So I got you a hint. I highlighted this part. So you might get a hint from what to do with 1 plus x square. Now can anyone tell me? 1 plus x square if we get, what we do with this? 1 plus x square आता है तो क्या करते हैं हम लोग? कुछ तो सब्स्टिट्यूट करते हैं ना, राइट? क्या सब्स्टिट्यूट यूज करते हैं 1 प्लस एक्स स्क्वायर में? स्टैंडर्ड ट्रिग्नोमेट्रिक सब्स्टिट्यूशन, इफ यू रिमेंबर. नो वन? स्टिल नो वन? इंटीग्रेशन पढ़ा है कि नहीं? साइन, tan इनवर्स. नो नो, आई एम नॉट टॉकिंग अबाउट द फॉर्मूला बेटा. आई एम सेइंग कि if I get 1 plus x square, I use a standard trigonometric substitution. I use the same in derivatives also. It is very famous. Sign नहीं है, sign नहीं है. It is based on identity. So 1 plus x square, say what hint I get, कि I need to substitute x equal to tan theta, so that this will become 1 plus tan square theta, which I can write it as sec square theta, right? So if I put x equal to tan theta, tan theta, that means dx will be equal to sec square theta d theta, and my limits will also change. It will become from 0 to pi by 4. What I'll get? I'll get log of 1 plus x, means 1 plus tan theta, upon, here I'll get 1 plus tan square theta, which is sec square theta, into sec square theta d theta. So this and this will get cancelled. Now I'll be left with integration 0 to pi by 4 log of 1 plus tan theta d theta. After this, what I'll use? I'll use king. King क्या बोलता है? Replace theta with pi by 4 minus theta. अच्छा, let this be I and equation number 1. So my I will remain I get integration 0 to pi by 4 ln 1 plus tan pi by 4 minus theta. This is the formula of tan A minus B. Do you remember tan A minus B? So ln 1 plus tan A minus B was tan A, tan pi by 4 is 1 minus tan B upon 1 plus tan A, which is 1 into tan theta. I can take LCM here. So if I take LCM, I'll get 0 to pi by 4 ln 1 plus tan theta plus 1 minus tan theta upon 1 plus tan theta d theta. Here ऊपर से tan theta will get cancelled. 1 plus 1 I'll get 2. So I'll get integration 0 to pi by 4 ln 2 upon 1 plus tan theta d theta. This is equation number 2. What we do once we get equation 1 and 2, we add 1 plus 2. So I'll get 2I is equals to integration 0 to pi by 4. Now let's check your log. Here, if I add this ln plus ln, do you remember the log property of log plus log? What was that property? It was log of m plus log of n. Then I'll get log of m into n. So here, this is m. Let me change the color. This is m, this is n. That means I'll get the multiplication of those two. So ln 1 plus tan theta into 2 upon 1 plus tan theta. As you can see, 1 plus tan theta will get cancelled. So I'll get integration 0 to pi by 4 ln 2 d theta. Simple. ln 2 is constant. So bar integration 0 to pi by 4. 1 d theta. What is the integration of 1? Integration of 1 is theta from 0 to pi by 4. That means this is ln 2 into pi by 4. This is the value of 2i. So what is the value of I? It will be pi by 8. 2 will multiply with 4. Here, pi by 8 ln 2. This is my answer. Again, it was a very good question. I would suggest to you that whenever I see lower limit 0, please at least try to use queen and king. I cannot use queen here. I checked that I cannot use queen. Did you check? Because the order of the property was ladies first. So first we had to check queen. I checked in my mind. Huh? You didn't check. I checked, and you can also check that queen will not be applicable here. By checking the conditions of queen, f of 2 pi minus x and all. So queen will not be applicable. That means the other thing which will be applicable in such cases when lower limit is 0 is king. So I used king and add. And similarly, I got the answer. I hope it is clear. Now, the time is almost up. But let me just brief you what we have done today. Recap types. We mainly did like how to use upper limit minus lower limit, and we mainly did the properties and some important questions. So next lecture, which is tomorrow, right? Today is Thursday, tomorrow is Friday. So for Friday, let me show you. I have some PYQs. I told you these PYQs are from the JEE Main 2020 and JEE Main 2021 sessions. So both of these I have compiled it and I have put it here. So there are questions, approximately 9-10 questions are there. We will solve all these questions tomorrow, and then we will move on to the periodic properties. The periodic properties, if you remember or if you know, the periodic properties of definite integration for periodic functions. Got it? So till then, I hope you got to learn today something new. and you enjoyed the lecture. We'll meet tomorrow. Till then, tata, bye bye, everyone. Bye 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 everyone. Yes.